Okay, good afternoon. Thanks to be here in this parallel session about the greening of research infrastructure. So we will try to be very efficient in order to make shorter the presentation, in order to have enough time that we have questions from the audience. We all of us already agree that we consider that this will be a priority as it's very important. So just to start with, in order to be efficient, so I will have very few words to tell to you. So the topic is greening of research infrastructure. And I think this is important, of course, for different reasons, but we will start with one, which is really trivial to us. I mean, we have to be more greener in order to keep our planet, and this is very clear. But also I will have an approach, I will say, very pragmatic from my side. My name is José Luis Martínez, by the way, and I'm chairing the ESFRI, who is the European Strategy Forum for Research Infrastructure. And one of the issues that we discuss now very strongly, I would say very deeply in the ESFRI, is about the sustainability of research infrastructure. And sustainability in the very large sense, of course, imply also the sustainability about the cost of the operation, and inside that, how the energy is used and how it's used in a way that is more efficient, and we have to achieve the same or even better quality of the research, excellent research, but we have to try to diminish and to control what is really the footprint produced by this research infrastructure to make more sustainable from the global point of view, including the financial sustainability of the system. So without any more, let's say, time, I would like to thank to all the members of the panel. I will not spend all the time to introduce all of them from the beginning, but I will give the floor to all of them to share with us what is the thinking they have about this issue, about to make the research infrastructure more efficient, more green, and sustainable. And to start with, the first presentation will be given by Mark Stickles. He is the CEO of the Pausley Supercomputer Research Center, who is the host institution for the Setonic, who is really the most powerful computer in the South Hemisphere. But even more important in this context is the energy efficient research computer. So this is really a very good approach. It's also really collaborating and dealing with the data with square kilometers array. So I would like to give the floor to Mark and to make his presentation.
So thank you and welcome everyone. I haven't got notes, I've got a support quokka, so if you know what that is. So look, on behalf of all of us here and... Oh! Sorry, hang on. Sorry, clear. No, it's okay, it's alive. I would like to acknowledge on behalf of all of us here that we're meeting on the Turrbal country and pay our respects as a panel and as guests on this country. As we had that wonderful welcome for those that were at the first session of the conference, it's great to acknowledge that. It's something we do here in Australia and it's very meaningful to us. I have a couple of slides. If I can...
No, that one.
Oh, wrong one.
That is a...
There's a pointer. I might have just pointed a laser at someone in the audience. So the reason I have a support quokka, and this will be a prize for the best audience question that we get when we get to audience Q&A, so I'm helping our chair, so it will go home with someone. But we've named Setonics after the scientific name for quokka, which is a unique West Australian marsupial and a bit of a symbol of a part of Western Australia. But for those that come and visit, you can get selfies with a quokka. But we are a national facility, as the introduction offered. We offer support to Australian researchers. We're a foundation facility supporting radio astronomy here in Australia, and we had some wonderful presentations earlier on in the conference that highlight the world-class capability we have here in radio astronomy. We're also doing some really interesting things in quantum, and there's some quantum hardware that we've pioneered some integration in at Pawsey, and a really important part of the national research infrastructure fabric of Australia is to have a facility like Setonics. We are part of the National Science Organisation, CSIRO. We're a partnership of universities, and we have state and Australian government investment to support our work. That is often the slide that you see. You'll see that wonderful picture of the white space. But for every square metre of white space that you see like that, this is also research infrastructure. So the need for advanced, the advanced computing infrastructure that we support requires some significant engineering and support to enable power and cooling. The stability of the service, the design of all of this is quite significant, and not many people see that. And so I just thought it was useful for this conference to see the full picture of what is digital infrastructure, and it still has a very significant engineering and energy impact that is evident in cooling and power distribution and redundancy and those sorts of things. What is important for us at Pawsey, though, is about being smarter about what we do, but looking at sustainability and innovation. We're a national lab. We're leading efforts in many ways to provide the most energy-efficient, high-performance computing we can to the country. The facility itself is designed with energy efficiency in mind. We draw several hundred kilowatts of solar power off the solar panels on the roof. We use the geothermal water underneath the building for cooling purposes. We have some innovation in the building design, but we're also pioneering some work in thermal batteries. So we actually have a CSIRO-developed cold battery store, so that if there's a breakdown in our cooling, they're pioneering some technology to allow us to provide some cooling if the power infrastructure fails. We've done a decadal study about the infrastructure impact on our aquifer. So we recycle several million litres of water a year through the systems to keep them cool. So they're just highlights of the things that we think are important in providing for a sustainable infrastructure and a continuing effort to reduce the environmental impact. Before I hand on to the next speaker, my summary points for my introduction. Clearly, we spend a lot of time thinking about the design and engineering of our infrastructures to best optimise the operations. We are increasingly looking at alternatives in terms of sustainable power. So in Western Australia, we are not on the national power grid. Australia has two large grids. One covers the whole of the east coast, and WA has its own power grid. That has a different energy mix than that of the east coast, and both of our grids are in transition. So the issue of sustainable power here is a very important one. We also, importantly, look at, and this is one where I think there's a lot of effort and a lot of opportunity, is about sustainable and optimised use. So advancing the better use of the compute hardware at Pawsey is something that we've put a significant amount of effort in, and we have results that demonstrate 60 to 70% improvements in efficiency and through just better code. So the days of asking for bigger compute to solve the same problems are being replaced by innovative approaches to software optimisation and improvement of workflows, so there's more efficient use of compute. The other aspect of that is the design of photonics and the accounting for allocations. Classically, you're appointed a major allocation of time on the system. We're engineering, we've written some papers on this about allocating energy use. So if you like changing, consumer behaviour by saying you only get a certain amount of energy to use, so your codes and your approaches need to be optimised. That might change some of the behaviour of our science community, which we wouldn't exist without them, so I'm not making that a loaded judgment, but it is something that indicates some different thinking about how we optimise use, that we design and work with our user community as constructively as possible. I think that's about my 5 minutes, I hope, and I look forward to joining in our conversation. Thank you.
Thank you. Thank you very much for this very good start point about the efficiency of the research infrastructure. So now, because we are efficient, we guys move to how is the point of view from Europe, and that will be a presentation from Yuri Demchenko. He's a senior researcher at the University of Amsterdam, but he is coming originally from National Technical University of Ukraine in Kyiv, Polytechnical Institute, and he is a specialist in data science, data management, and actually he is a coordinator of the Green Digit project of Europe that is really trying to make the recommendation about the technical operation and policy recommendation for the greening of future research infrastructure. So I think really in the core business of this panel. So please, Yuri, and this is your pointer.
Thank you. So I will move for. Thank you for the introduction. I will move to our. I will move to. Yes, I was not so tall. So this is a introductory slide for the my presentation and Green Digit project. It's a good introduction. First was a message from Mark, because data centers is energy efficiency and environment impact is well developed, supported by many standards, regulation, certification, and so on. The same in Europe. But research infrastructure is much wider than data center. It's starting from data center, communication, research facilities, and also research tools. And this is actually the main goal of the Green Digit project funded by European Commission. And this project will work for ESFRI research infrastructure. This is José Luis' domain. So we will try to provide recommendation, all range of recommendation. I will show you in the next slide, to make research infrastructure more energy efficient and less environmental impact. And interesting that Green Digit project includes 4 infrastructures. This is eBrain. This research infrastructure, this works for a brain research. EGI, it's our European biggest infrastructures that support almost all research in Europe, providing super high performance computing. Next project is a research infrastructure slices. And this research infrastructure is focused on experimentation in ICT technologies. This means that we need not only collect data, distribute, process, we also need to manage experimental facility and achieve reproducibility. And so big data is a research infrastructure that does social mining, social reasoning. So we will find two infrastructures are digital and 2 are not digital. So we will try to find a symbiosis between digital infrastructures and how a general infrastructure that use digital technologies can be connected, and what we can provide in the sense of digital technologies. And a Green Digit project focus on 3 main domains. What is the specific of these main domains? First is energy efficiency. Energy efficiency starts from architecture design and recommendation, how to do research application. Next is a decarbonization. Decarbonization happens that data centers, research infrastructure consume a lot of energy, and how we can estimate CO2 impact. And another one is reducing environmental impact of digital infrastructure. And this includes also very specific topic as life cycle, because we buy equipment, we install it, after that we modernize them, we need to make the right procurement of equipment, and in this case, achieve some less environmental impact. Also, the last stage is decommissioning, what we will do with this equipment. And Green Digit also defined 5 objectives that cover all aspects related to the research infrastructure existence, installation, and operation. First is assess the status and trends of research infrastructure in Europe. We investigated this. We made this landscape analysis, and it's already created us quite clear vision what we need to improve, how we can transition, allow infrastructure transitions in the future. Project already has 8 months of operation, and we already have some results that I will try actually to present in this, my introduction. Provide reference architecture. It will be next slide, because reference architecture will provide a common language for all aspects related to sustainability of research infrastructure. And develop tools for operators and for researchers. And not less, the O5 is education. Education that need to be, and training that need to be provided for all stakeholders of the research infrastructure. And if you go to the proposing what this project proposes currently, we realized that then we started working on the project and solving, understanding what we need to propose to community. We came to the conclusion that we need to propose shared responsibility model. Shared responsibility model that actually include responsibility of providers, operators, and research infrastructure in the form of research infrastructure facility, scientific workflow management, and researcher tools. And here we also found that here we also have a place in interest from research tools vendors. For example, math labs, MathWorks, they are already happy to cooperate with us to make in their tools include something related to sustainability, energy efficiency. And if we talk about how to realize this, we come to the conclusion that we need to address at the sustainability by design. This means defining KPI, API, also information model. And to show you how we understand this sustainability by design, I show on this slide which areas of infrastructure structure layers we address, including from architecture to software, common information model. And this I specifically want to stress, common information model is very important for sustainability. Because if you see a previous presentation during this, even today, we see that information needs to be exchanged. How information can be correctly exchanged if it has a common information model, common metadata, a common namespace. Okay, hopefully it's enough technical introduction.
Thank you. Thank you. Thank you very much, Yuri. So we continue with this efficiency. We come back to Australia, and to change also the mind, we go now to a provider of service, Amazon Web Service. So we have, please, Karina Kem, who is really, she is the responsible of the global lead for academic research at Amazon Web Services, is collaborating with the global research community to explore how digital infrastructure can enhance research capability. So I give the floor to Karina, and please make your presentation about your point about greening of research infrastructure.
Thank you very much, Jose. Okay. Thanks for the introduction. I work for Amazon Web Services. I talk about being a recovering academic. So I used to be a researcher, and now I love working in the community enabling research. And I've gone from working in research infrastructures to now working for a vendor supporting research. So it's a really interesting perspective. I just want to talk today about some of the things we're doing at Amazon. So from the very beginning, we're part of the Climate Pledge. We're founders in the Climate Pledge, and we really take this seriously. Everything from the packages from Amazon the business, through to what we're doing in Amazon Web Services. We have 500 plus renewable projects across the globe that are supplying renewable energy into our projects. We've actually, I didn't mention this, we've reached our goal of being carbon neutral across the organisation this year. Our goal was to actually reach that by next year. Now we're working towards positive water. I'll talk more about what we do to do that. Everything from the buildings up, we talk about with sustainability. The other things we bring into our conversation about sustainability as well is things about human rights, thinking about the whole sustainability development goals as well, bringing it holistically in, transportation of our kit, specifically for Amazon Web Services, how we move that around, how we deal with waste and circulation, how we do with water stewardship as well. We make all of our results public. I have our sustainability report here if anyone wants to look at it, but it's also available online. Now, I love the shared responsibility model. We think about shared responsibility model when we think about a lot of things we do at Amazon Web Services, from security to sustainability through to a whole lot of other different perspectives. Specifically, when we talk about this, we talk about sustainability of the cloud. So we're responsible for making sure that the tin and the building and the networking and all that sort of stuff is being built in the most sustainable way we can. Everything from working on building our own chips to make them more efficient and more sustainable as well. Then the sustainability in the cloud really is the responsibility of our users, but we provide guidance, best practice on how you can build your codes more efficiently in the cloud and that sort of things. And then I think we can't forget in this conversation, and we've heard about this this morning as well, is what is the infrastructures doing to provide that sustainability research as well, right? So we can't forget that we need to use some of these resources in order to be able to do the work that we need to do into understanding the climate. I'm done.
Thank you very much. So now we switch again, and now we will have the perspective from the American side. We have here Slava Lukin, who is the program director inside the National Science Foundation, who is really the independent agency in the United States who finances quite a lot of the support, the science and engineering. But in particular, Slava Lukin is really his technical background is coming from computational space, plasma physics, and high-performance computer. So please.
Good afternoon, everyone. Thank you for inviting me on this panel. As was said, I'm Slava Lukin. My background is in computational plasma physics, high-performance computing. For the last 10 years, I've been in a funding agency, mostly declining proposals. So, your condolences are appreciated. So, NSF is the U.S. National Science Foundation it's not the biggest science agency in the U.S., but it supports science and engineering across just about the full spectrum. And one wonderful thing about working at the NSF is that I have hundreds of colleagues, scientists, many of them active scientists, who I can come and ask questions, and then we have easy access to many of our principal investigators. So you end up with thousands of people who can go and ask a question, and you'll hopefully receive an answer within a day or two. Really world-leading experts in just about any topic. So I did ping a few of them before I came here, because my personal expertise is not really in environmentally friendly research infrastructure. But NSF supports research infrastructure all across the world physically, right, in Chile and all over the place. And some of the research infrastructure is just energy hungry, right? You've heard about compute. You might have heard about particle accelerators, right? CERN, of course, that's not an NSF facility by any stretch, but we do play there. And the power consumption is pretty massive for some of these particle accelerators. Some of the research infrastructure isn't simply in hard-to-reach, delicate environments, right? Mountaintops in Antarctica, and so one has to worry about the environmental impacts there as well. So, both environmental and cost of operation, we are a funding agency, cost of operation factors are considered when a RI is being developed or upgraded. So before I go to the next slide, imagine that you're in a rush, on a plane on a very important trip, or, your close relative is about to give birth and you really need to be there and you're running late, right? And you're on a highway, probably speeding, and then there is like a traffic jam or construction in front of you. Right? So put yourself there. Okay. Science funding agencies, such as NSF, do not set environmental energy policy. That's somebody else's job in the US government. So we live with the policies that somebody else supports. Okay? Somebody else came up with them, right? So NSF actions at any given time have to be consistent with the policy sets elsewhere in the US government, and of course for research infrastructure that might be elsewhere in the world, of course it's going to be also subject to those local regulations. So that's one constraint that we work with when we make decisions. The other, however, on a maybe more positive side, and sometimes, is that our decisions are really heavily driven by the input from the science community through our peer review process, which is, I think, respected widely all over the world, and has been done, for decades. So we have these two constraints, if you like, or however you want to think about it. But there is a government regulation, and then there is community's voice, which is extremely important for us in anything that we do. one thing to remember when we talk about research infrastructure, right? These things from conception to when they turned off in some way, right? The life cycle is often quite long, in decades, right? And so that's a time scale. But the time scale of national politics or technology development these days especially can be much faster. So that's something that has to be considered when we develop infrastructure, right? When we talk about it, when we begin to planning about it. So for example, right, individual research infrastructure operational sustainability, and here by sustainability, I mean actually maintaining the facility, running it, right? So it's not subject to those cycles. It really has to account for the variety of factors which change on a different time scale, are external to the facility, and you have no control over. But so you have to keep that in mind. On the other hand, as a funding agency, lower cost of operation per unit of science delivered, however you want to measure it, is always welcome. It's certainly always welcome by the taxpayers who actually provide the money that we use as a science community to do our research. So that's an easy justification. Finally, evolution of scientific community practices, in particular in terms of environment and energy consumption, can be driven by both mandates or by incentives. And that's my personal opinion here, that incentives, as opposed to mandates, although sometimes mandates are necessary, but incentives as opposed to mandates may provide a more organic and thus more sustainable, again, in a sense of being there over those timescales, evolution pathway with fewer uncertainty side effects. And so as a plasma physicist, we're all about nonlinear physics and collective interactions, and I approach the societal, social engineering aspect in this very similar way. So thank you.
Thank you. Thank you very much. So we try now to have some kind of discussion. I prepared one question, a couple of questions, but really think about question for a few minutes, and we try to be efficient and give the floor to you. But my first question will be to continue with the things you just prepared. This kind of dichotomy of dialectics we have between, let's say, interest from the user's point of view, academic one, we'd like to have the result as soon as possible because it's a thesis involved, and his project has been probably evaluated with a peer review. They want to really implement it. And also, they say, the point of view of the people who finance the research infrastructure, or even the manager of the research infrastructure, of course, that they want to maybe go to a process to be more efficient. So and also I connect with the model about to be very inclusive, and how do we make this kind of model that the decision process is really taken by the full partners and the full stakeholder of the system. So my question in particular, coming from this theory to the practice, how you will implement that in the real case of really one research infrastructure dealing with the digital aspect, or even not digital aspect, also analytical facility or whatever. How really do you have the tools or the ideas how to really implement it in reality? That. So I don't know, we want to start?
I might kick off just from an Australian context. We have, as it was mentioned in the introduction, we've had a long-term commitment to national infrastructure, research infrastructure investment, and that follows a particular national cycle and a government cycle, but it's also supported by investment within different states. And so the bringing together of that and the planning exercise isn't entirely consistent. And so there's a regular challenge of renewing national roadmaps and engaging in the best sort of local regional needs that we can secure. And with a very distributed research university network and a very broad national science agency, lining up all of the discipline opportunities with the funding opportunities at state, government and at local level, I could argue it needs a supercomputer to help work that out, but the cycle for these things don't often align well enough with the opportunity that's presented by the science. I will offer one positive, and it does seem to be a long time ago, it wasn't that long ago, but there was a really positive coming together, particularly in the high-performance computing community around the response to COVID, and actually bringing those research infrastructures to bear together across national borders. So it can be done, but it's not, I think it's not naturally an easy thing to coordinate and plan, even though that planning is needed.
I can, yeah. Okay, so I very like what Slava told. It's incentives and criteria. Need to be, because funding agency, but I'm not funding agency. I'm a typical applicant, proposer for the proposal. But Europe is already moving in this direction. And here I simply, what I guess I will not interfere that José Luis, because new ESFRI roadmap already included as a criteria environmental sustainability. Another interesting aspect in making this criteria is that sustainability until now, or recent year, was used in sense of financial sustainability, life cycle sustainability. So introduction of environmental sustainability will make a serious change. It's already established criteria, what to do. And one of the interesting criteria of assessing proposal for environmental sustainability is an assessment according to European sustainability requirements and criteria. It is linked to around 17 standards international. This is side of application for funding agency. But what does researchers and academia, means education, education try to include, at least University of Amsterdam, try to include sustainability aspects in almost all courses related to from business to social and to computer science. And we try to coordinate this. Again, sustainability is a very overloaded term. So we will work, and this panel is extremely important because we try to collect opinion, try to understand what people think and how we can cooperate.
I have something to add. You know, at AWS, we work with both individual researchers, research infrastructures, universities that are trying to support their researchers. And we see sort of there's a number of different reasons that they come and use the cloud. You know, there's some, but a minority, I wish there were more, some come because they see sustainability as an easy thing to potentially tick the box by leveraging Amazon, right? We can help reduce, you know, they don't have to worry about those things themselves if they don't have access to some of these amazing infrastructures like Pawsey and things like that. The other thing that I think is really interesting is, you know, ironically, you know, the cost is comparable to the, you know, the carbon footprint of the compute, right? So I like what Mark said before about, you know, starting to make it more transparent to researchers about what they're actually using, you know, so they only have so much, you know, what's the carbon they can use or the energy they can use at the infrastructure. So we see that a lot because a researcher wants to actually, you know, make sure that they use only what they need in the cloud because they have to pay the bill for it. So it actually makes it a lot easier for them to think about it that way. Thanks.
Well, I can only echo what was just said and back to what Mark said.
I didn't know you could sing, Slava, but that's okay. You'll sing this one.
So I think the incentives and making things transparent to the researchers, right? And often it comes down to, and this I go back to my researcher days, when something is not working. When something is free, right, and your time is not, you make a choice. Every one of us, right, makes a choice to do something quick because your time is not free, right? Maybe you want to head over to the happy hour. I don't know, right? And we don't always, as a scientist, we don't always choose the right model, even the right code, to really answer the science question you're after. You may be using something that's more convenient based on your personal constraints. And so providing those incentives and constraints, which often means money in one form or another, is really important if you want to try to optimize the system.
Okay, I will try to make a second question to give you the floor, just a very quick one. It's about one of the comments you make about the lifetime of the research infrastructure. So I would like if you can elaborate a little shortly, because we give the floor to the people. It's about during the lifetime, this kind of consideration of environment and greening and more efficient, how is really taken into account? Because you have from the beginning, for the design, you have the procurement of the different things, finally the operation, where really probably the electricity cost is very important, but you recover also some energy, you do efficiently, and at the end of the day, it's the end of your facility in the sense because maybe the technology is becoming not in the cutting edge that we would like to have. So how is either is it dismantling or even the reuse of this kind. I'm thinking especially in the digital research infrastructure, who probably has a very quick cycle of maybe 4 or 5 years. I mean, all the CPUs can be reused in different contexts and really still have a lifetime. That is really part of the efficiency, global efficiency. So maybe you can elaborate very quick ideas on that.
So very quickly, I actually have a liberal arts background, and I was thinking of a philosopher that said something about things being nasty, brutish and short. The infrastructure cycle of advanced compute is fairly aggressively managed, and so you want it to be as efficient and as sustainable as possible. We do recycle the hardware is returned to the vendor in our case. We recycle the water. And we also, importantly, in the procurement processes, have some guidelines around energy efficiency and sustainability, but it is an evolving space that we need to do more in.
I can comment as well. I mean, similarly, we recycle our chips if we can or resell them, our hardware. But what is really interesting in recent years is we've been actually also investing in making sure like the buildings, like the concrete, we're researching into building, making sure that's as carbon neutral as possible and working with the research community as well to, you know, what tools and our steel as well. You know, there's a number of things as well. So looking at the whole thing from the building and the water and everything.
I'll only add once again that the shared responsibility model is very important because it's not just the building and the machine, it's the people, right? It's the people, it's the users, and how are they again using the infrastructure in the most optimal way? How much time are you going to be spending when you're changing the hardware all the time? Is that really the right thing to do? Right? Many of us want, especially again in HPC, right? The reason the cycle is so short, not because it really has to be that short. It's because everybody wants to be up front. Is that really? I mean, you know, when we start talking about this, is especially in very constrained environments these days, is it really? And I don't believe I'm going to say this, but I will. Is it really in our human self-interest to make progress of science as fast as possible on every front? Is that really true? Let's, you know, maybe that's a conversation over beer later.
At what cost?
Yes. Exactly. At what cost?
It's very philosophical.
Open to the audience, I think.
That is last one. Yuri, 1 minute.
Okay, I want just say, then we did first stage of our project, the so-called landscape analysis. We talked to few infrastructures, research infrastructures. We have like 50 questions according to different criteria standards. But what was interview, they made request or message from our interview at research infrastructure. We need some kind of well-defined guidance. We cannot read all this auditing, certification, and standard documents. Write something in the form of white paper that doesn't use a language of standards.
Thank you. Was a question there? Please identify yourself.
Yeah, Donald Hoban from the Australian Plant Phenomics Network. This is particularly following from some of the things that Mark and Karina both touched on. Obviously, for the computational infrastructures, the software, the characteristics of the software are a very big part of the overall efficiency of the use of the infrastructure. And yet, surely a lot of our software is written by researchers who have become software developers as a side skill. Is there anything you can say about how we should be looking at that overall model and perhaps bringing software engineers and those with understanding of efficient use of the processes we have more into the mix for development and management and certification of the software itself?
So a great question. Quokkas eat plants, so they're not a carnivore, so they thank you for your work. We invest in infrastructure and think of the hardware, but we also a greater need in the area of investing in the software, in the case of compute, in software. So the refresh project for Pawsey had a parallel project in investing in, if you like, extreme compute scale readiness or transition to GPUs in many cases. And we invested in that as part of the technology refresh at Pawsey. And that follows a model of a number of the major facilities in the US that have that sort of readiness and transition program that requires compute and software experts to work with domain experts. And that's, I think, a growing need here in Australia. And there has been a number of domains that have come together in Australia in recent months to make submissions for our international guests. We're going through a national digital research strategy process. And that particular issue that you've identified is one of those key themes that we're seeking further support in the next infrastructure roadmap. So thinking of software as infrastructure and the skills needed to optimise these sorts of hardware is absolutely a top of mind interest here in Australia.
And I'll just say what some of the things we do. So obviously training is massive, right? Like, so cloud is a new way of doing things. You can do everything and anything in the cloud, and it can be quite scary. When I came into this role, I found that a lot of our training materials were targeted to software engineers. And I'm like, well, we want researchers to use the cloud. So we're pretty excited this year. Just last month, we launched researcher-specific training. It's only the beginning, but it's like, how do we actually think about what researchers need and what they need to learn, and what does well-architected look like for research software in the cloud? We're still only early days, like there's some time we have to go. But the other thing as well, people don't realise we have what we call solution architects, which are sitting in most universities and research infrastructures that are Amazon staff that sit there and help. And they're a resource that's available for researchers to use as well. And so we have lots of people that are available and really interested to work with research, because it's much more interesting than working with a telco or a fintech, like work with a researcher. Thanks.
Thank you. No more comments?
Okay, yes. I want to just echo two comments about Karina's, that yes, Amazon Cloud provides extremely rich metrics for assessing energy efficiency and optimization. But how? They provide some tools, but actually researchers or developers of software developers need to develop some tools. So we understand that we need to provide researchers with special plugins, libraries, that allows to connect to different sources of information, not only from providers like Amazon and cloud provider, but also from databases that do regional and different kind of assessment of energy. We will be working on this, but this will help researchers as application developers to make decisions.
Thank you. Next question is here.
Hello, I'm Jane Fitzpatrick from the Australian National Fabrication Facility. We, 5 years ago, sustainability wasn't on our watch list at all. It wasn't in our reporting. It wasn't in what we were doing. And it actually started from a group of our engineers actually getting together and starting an expert working group on sustainability. And from that small start, they have started getting accreditation in My Green Lab and other accreditation facilities or abilities. And they've also brought it into what we do, so that there is a sustainability KPI for every one of our nodes, because we're situated within the university, so we can't change our energy mix. We can't deal with our water. What we can do is make sure that we reduce the water that's going through our particular instruments. So looking at what we can do, and they've actually managed to change the way we look at sustainability from too big a problem to we use a lot of overshoes. How do we change that kind of thing and not put that plastic into waste? So maybe just a comment on, there's other things other than energy. What are the other things that we can work on, and how do we engage from the very bottom up, not just from the top down?
So I of course applaud you, and NSF is one thing I didn't quite say, is really a bottom-up agency. It starts at the science, the community, then goes up to program directors and up. And as I pointed out in my slides, the review process, the community review process, those initiatives, even if there's not a mandate, right? Or even if there's not an explicit incentive, if the community is receptive, which I think generally scientific community is receptive to these topics, if you show the initiative, one of our review criteria is very broad. It's called broader impacts, which every proposal has to address for decades. And you know, if I had to predict, I would predict you'll get a lot of brownie points from the reviews for doing something like that.
Thank you. Some compliments?
Well, I'd give Jane a compliment. She's, as the current chair of our directors network in the ENCRIS community, I'd just give her a shout out. If anyone wants to talk more about how we affect change across our sector, she's a great advocate for it. So I just give her a shout out. Yeah.
And I was just going to say, I agree with you too, Jane. It's more about electricity, and we do not silly things, important things, but like we used to have, you know, we're a tech company, we have some free food in the office. It used to be in individual packets. Now it's actually in Tupperware, and we actually have a recycled, you know, a washable plate that we get it in, right? So we're thinking about holistically waste. And on top of this, we survey all of the staff as well to understand what do you care about with sustainability. So it's really kind of ground up. Driven.
Thank you. Question there at the back.
Yes, thank you. My name is Adam. I represent a national agency supporting researchers in applying for funding and international collaboration in Poland. I have a question. Do you think, does the size matter? I mean, is it the bigger infrastructure, the easier the greening process is? Or the opposite, the smaller infrastructure, the easier process? Or maybe it's about a completely different thing, the level of advancement of the infrastructure, the more advanced, the more efficient, and so on, or not? How do you think?
Go ahead. Difficult question.
Yeah, so I'm not sure that, I honestly don't know, maybe somebody has studied the topic, as to the scaling between the size and easy. I mean, there is often critical mass for many activities, right? Once you have a big enough team, you can worry about something. So in that sense, maybe, but going back to high performance computing and the scale, what at least in my experience in the communities I interact with as a program director, often for a variety of social reasons, we want to do the biggest simulation possible. That's just always been the case. You want to do the biggest simulation possible. Sometimes there are incentives which are artificially created for that, but you just want to do the biggest simulation possible. Now, is that really the right thing to do for answering the science question you're after? Sometimes, right? Sometimes doing 10 simulations, each of which is 10 times smaller, will actually give you a more robust science answer. And the community doesn't always think about that, right? So, sort of, you know, not direct answer, but maybe if you have a machine which is 10 times smaller, therefore it doesn't have to communicate as far. It actually eats up less energy, right? From a HPC perspective, and you may get even a better science answer.
Just
compliment.
Yeah, a quick addition. Two points. Water is a very precious resource in Western Australia, and in hosting a national facility like Pawsey, we had to innovate in terms of how we cool, because we don't have excess water. We use the state's, the city's drinking aquifer water is a supply for Pawsey's cooling. So we innovated about how we manage that. The other point I would make is that the size and rankings we've got some of the directors of some of the biggest facilities in the world here at this conference. I saw Professor Satoshi and Thomas Schultes, Dan from TAC, major facilities. And what's important is that in Australia, we collaborate well, and a shout out to a small number of researchers in Australia who could probably use the biggest systems in the world. Doesn't mean we need to be the biggest system in the world here. A Gordon Bell Prize, the Nobel Prize for HPC, was awarded a couple of weeks ago, and it was an relatively young Australian research team that had used both the national facility at ANU, had used the Pawsey system, and has scaled their work to run at Oak Ridge and doing some really advanced quantum chemistry simulations and testing the systems at the biggest in the world. So there's the right sort of, my short message is the right sort of strategic investment nationally and being part of international collaborative sort of networks is a message of this conference, and it's also evident in the right sort of investments I think we can make and how we partner and work internationally.
Thank you. Good message. I think we have last question.
Karthik Sheth, NASA. Referring to researchers and their role in personally taking responsibility for being more sustainable, I'm wondering if there already exists or encourage you to think about offering sort of prizes for young researchers to develop the most energy efficient software, or it doesn't, like, this would be a very quick return on investment, and it would be great for getting this into the culture of early career researchers, since that's what we're talking about today.
I have something to comment on that. So we have a tritium chip that we've designed that's more efficient than an NVIDIA GPU, right, by 60%. But our researchers know NVIDIA GPU, they know how their software run on it. So I am at the moment trying to think of some innovative ideas of how I can work with the research community to get them to start building some of their software on the tritium chips, because we see that that's where we're going to see the innovation. So great idea.
Thank you. Are there more questions? So
Can I award my quokka?
sure.
I think it's the big question. Can I give the big question to the quokka? So if that's going to head somewhere back to Europe, I'll catch you afterwards and give you a quokka.
Thank you very much. So thanks very much. So I really thanks all the panelists and all the public here for this panel discussion, and thank you very much. Okay.